Okay, very nice, Evan. Pink, very beautiful. All right, so what I'm going to do is get this started. I'm going to get it recording and then, oops, and then we'll go ahead and try this warm-up problem, and then I'll let you guys know what we're doing today. So let's get our meeting going. What is this? This is Core 1. This is your webinar, and you guys, we are now in week 10. Amazing. Okay. All right, so whoever just came in, Ivy and Alexis, I see that you guys are in. I don't know if you guys can hear me or not, but I can see you back there. Okay, so look at this diagram. And this diagram has to do with some direct variation. So what you want to know is what general rule you can use to model this situation. And like I said, this aligns with our direct variation that we're doing in our unit. So the direct variation was from last week, week 9. This diagram shows how long it takes to hear thunder after you see lightning. And I'm sure you guys have heard that, right? If you're standing around and you hear thunder, and then all of a sudden lightning comes really close, you know that it's really close to you, right? And there was some rules you guys probably heard about where if you hear the thunder and then you count 1001, 1002, and you can kind of get an idea of how far away the lightning is to hitting you. So in this situation, well, Evan coming back in. So in this situation, oh, hi, Ivy. Yeah, you can finish your math test. Of course, you can always take a math test. That is always a good excuse, by the way, just so you know. But anyway, so in this rule, there's the lightning. Oh, we've got Layla and Skylar. All right, good. I'm glad everybody's here. So how are you guys, Skylar and Layla? It's good to see you guys. But anyway, so look at this little example. See where the lightning strikes. Okay, and it tells how far away the person is on either side. So this girl, the lightning strikes, and then she hears the thunder 15 seconds later. And then for the guy, the lightning strikes, and he hears it 10 seconds later. So let's think of a general rule to model this situation. Okay, and when you guys are thinking of your rules, okay, that's good. That's good. Janae, can you see okay? Okay, good. So when you guys are thinking of direct variation, because you want to model this with direct variation, if you remember that direct variation is really just a linear equation, it's really just y equals mx, but with no b. Okay? And m, just to give you guys a hint, m is the same thing as k when we're dealing with direct variation, and we also call that the constant of variation. Okay. So what I want you guys to do in your notepads is I want you guys to think about, oh, sorry, Skylar, that's a bummer. Janae, you can't control the shared screen.
I'm sorry, I'm trying to get out of this.
That's okay. I just see it's really weird because I'm like, Janae requested to control the shared screen. Well, that's good. That's good. If you want, you could do it. So what I want you guys to think about is what is that variation? You know, X and Y are varying directly by some constant of variation here, and you get two examples where you get this guy who hears it after 10 seconds and he's 2 miles away, and this girl hears it after 15 seconds and she's 3 miles away. So can anybody write in their notepads what you think that constant of variation is? Ash, I just got a note from you. I have to quit for just a minute. Okay, so I want you guys to think about that. Do you guys see anything that is constant between how long it takes her to hear The thunder versus the guy after the lightning strikes. Ashley is typing right on, Ashley. Oh, I just wondered, like, if you look at the picture, can you see anything that's constant in how long it takes her to see the lightning, or not see, to hear the thunder versus how long it takes the guy? There's some kind of constant in there, right? She's 3 miles away, and it only takes her 15 seconds to hear the thunder. He's 2 miles away, and it takes him 10 seconds to hear the thunder. So, oh, Leda, so 5. You think the constant of variation is 5. Very good. So, Leda, since you are, and Ashley is typing 2, nice. They are divided by 5. Okay, so yeah, Leda, what you can do is write in your box how you got 5. And Skylar is in process. This is good. Oh, and if you guys don't have a box and you want to type in, because I know there's not enough boxes for everybody, you can type in the chat, because everybody can type in the chat if you need to. So some of you guys already have notepads, and that's great. But if you don't and you want to participate,
so we just have to figure out Y or M.
If you can, exactly M. You are right on. And if you can figure out M, like Leda figured out M, and so did Skylar, and it looks like Ashley did too, then I want to know how you got that. So you looked at the distance to, Leda, you left off. Yours, yes, yours does actually. Yes, yours does, Ashley. Very good. I'm just going to let everybody have a little bit of a chance. That was a big, big T.
Are you in right now?
Uh-huh. Oh, sometimes you have to restart those. I noticed. It's really strange.
Okay.
So you looked at the distance to, so Skylar, you looked at the distance between the 15. So Skylar, between the 15 and what exactly? Janae, what do you think?
I don't know where they got the 5 from.
That's okay.
I'm so confused.
That's all right. Just keep thinking about it and look at their explanations maybe too, and look at Ashley's too. She has one in there too. So you looked at the distance to see the difference and then subtracted then by 15. And then Skylar said the distance between the 15 and 10. Okay, so you guys are looking at the difference between 15 and 10. And then Ashley, did you look at the 15 and the 3 versus the 10 and the 2? Mm-hmm. Okay.
Oh, Lord.
So, Dustin, you are no comment. How about you, Evan? Any ideas? And the difference of the subtracted 10 by 15 and the difference of the 3 and the 2. Ah, okay. So Leda, I think what you're saying, it sounds like you're saying you actually took the slope is what you took. You looked at those as 2 separate points and then you took the slope.
So basically, all you guys are adding is the miles.
Well,
So there's 2, it's 2 and 3 and it equals 5.
that's true. I think that's just coincidence, though, that equals 5. Yeah, the miles together. But it looks like, so Leda has something interesting because she actually took the slope, which is what you would normally do. She went and found the slope between the points, and so that's a really good method. And then Skylar said the distance between the 15 and the 10. And you can do that, Skylar, because on the slope, oops, central classroom, here we go. And because the difference of your x's, if you consider the miles to be your x's, is only 1. So then you only have to look at the difference in your y's. And then Ashley, very good. I know Ashley did, she looked at 15 divided by 3 and got 5. And she looked at 10 divided by 2, she told me, and got 5. And so that's good, Evan. That's totally fine. Dustin? Can't believe you don't have anything to tell me, Dustin. Okay, so let's look at this. You guys have really, really good logic here. So whenever you're doing direct variation, the nice thing about direct variation, because there's only an m here, there's no b on the end, then you know that x and y vary directly by m. So really, when you're doing slope, you don't have to do a full slope. If I go ahead and I make these points, so say that my miles are x, so that's 2. Oops. And my seconds are y, and that's 10. I only need 1 point, and I can figure out my m. I can figure out my slope. All I have to do with that 1 point is take that 10, which is my y, right? Because slope is always y over x, and divide it by x, and I get 5. And you know that you have direct variation if you can do that for every single point. So I have another point, which is 3, 15, and I can do the exact same thing. So if I take the 15 and I divide it by 3, do I also still get 5, guys? Yeah. Yes, I do. So I know that I have direct variation because each of my points, x and y, are varying by the same amount. I have the same ratio. So that's the nice thing is that, Leda, that was awesome that you did a slope. That was beautiful. And Skylar, you kind of did the same thing too. But in reality, you can take a shortcut and you can just take one y and divide it by its x, and you get the variation. So the constant of variation is 5, and your direct variation equation then is just y equals 5x. So that means, and we said that y is seconds, right, and x is miles. So when lightning strikes, they vary by each other by 5 seconds. Okay? So very good, guys. Any questions? Y is our seconds on that one, yep. Yep. Our total seconds. And then our x is our miles. All right. How are you guys doing? Skylar, you're leaving. You're leaving us. Okay, that's fine. Dustin, it's okay. As long as you start typing in your notepad, I'll forgive you. It's all right, Skylar. It's all right. You have a good day. I'm glad you came in for a little bit. All right, you guys. So no questions at all on the direct variation? We'll see ya. All right, so think of direct variation as just y equals mx plus b, but without the b. So that means that all the lines start from 0. All right, you guys. Let's see what we're going to talk about today. So today's objectives, I want to go over the expectations for finalizing your quarter grade. That's really important, right, since our quarter grade is due on Thursday. So there's only today and tomorrow, really, right?
How much did you say they have it by Wednesday?
By Wednesday? That's probably a good, yeah, that's probably good, Jenny. If you get all your stuff in by Wednesday, that way if there's any mistake or anything like that, you can talk to your teachers or the teachers can talk to you. So I want to talk about that, and then we want to go over maybe some questions if you guys have any questions on any of the material that you're learning. And then the final thing I want to do is just a little review on how to write a linear equation from 2 points, because there were some questions on that before. So, good, Dustin. Glad there's no questions. Awesome. All right, so you guys, finalizing your quarter grade. So you guys all know in here that in Unit 1, there is a mid-unit exam, right? And then there's also a final unit exam. So in week 5, oh, Shoshana is here. So in week 5, there is the mid-unit exam. So let's put this in here. So week 5 is the mid-unit exam, and everybody needs to take that, right? Because even if you started late, we're in week 10 right now, you would have to start 5 weeks late, and you'd still be on target to take the mid-unit exam. So everybody needs to take that in order to get a quarter 1 grade. Okay, and then if you've been around, so meaning that you started in late August or in early September, you need to take the test that's in week 7. Okay, so that's your final unit test. And you really need to do that so that you don't start quarter 2 at a huge deficit. And that way I can give you a passing grade, assuming you pass it, of course, you have to pass it, for the end of the quarter. But then that puts you at only a few weeks behind. And in week 7, really, the main thing is just the test in there. So if you think about it, the material you have to get through, and many of you who started late, I'd let you skip week 2. So you really only have weeks 3, 4, 5, and 5 is a test. So 3, 4, and 6, 3 weeks of big material to make sure you understand. So does anybody in here have any questions about what they need to do to pass for the quarter? Sinead? Go ahead. I did. I put it all the stuff I put on your sheet is all that you need, and you'll be good. Yeah.
I got half of that. I just need to do
And then you are golden. You're good. So yeah, so you guys, okay. So Dustin, are you still no questions over there? And Evan, how about you? Oh, Evan, I started last week. Do you want me to take? Yeah, Evan, if you can get to it, I think you've been doing really, really well. I sent you a message too in Schoology. Did you get my message? Okay. You're deleting. Okay, yes, you did. And you finished week 3. Awesome. Do you think, oh, go ahead. You finished week 3. And you know what, Evan, actually, if you want to hang on here at the end too, I have my paper that has what you've got on there and what I sent you to. Dustin, you're good? Okay, that's good. Okay, you're taking notes. Okay, good. And I think, Evan, if you can get to the mid-unit exam, because if you already are done with week 3, and like I said, at the very end, I'll go ahead and grab my paper. I don't have it right now. Actually, maybe I'll. Hey, Ashley, you're doing a huge favor. On top of my, see that green binder? There's 2 sheets of paper under my phone. Will you grab those? Awesome. So I'm sending Ashley out, so she's going to grab my papers for me. Okay, Evan? And then I think, I don't remember, I know you started last week, but it seems like you were doing really well and you were on track anyway. If you started within the last week or 2, there is a chance if you're making daily progress that I would give you an I and give you an extra. Oh, so you did leave off what we were doing in week 3. So you understood that already? Evan. Ah, yes, I see you on here. Okay, so yeah, I do have that you were a late start. So, okay, so you know what, Evan, if you feel really good, go ahead and go to week 5, and that goes for anybody. If you feel really good about the math, go to week 5 and check out the review. There's a review in there. You don't have to submit it for a grade if you don't want to, but check out the review, make sure you know everything. I also have provided an answer key in week 5, so you can open up the answer key and see if you know that material. If you feel good, go ahead and take the mid-unit exam. And Evan, if you can take the mid-unit exam and pass it, then you don't need to do weeks 2 or 3, 4, and 5. You can just skip those, actually. How's that sound? Week 5, yep. Exactly. You got it, Evan. You totally got it. Yep, you're right on. So if you can pass that mid-unit exam, but just make sure you check the review out first, just so, because you only get one shot at taking the test. Obviously, if you failed it, then we would talk and you would start from week 3 and work your way through. But and then we would work something out. But yeah, if you feel good and if you were already in math, then you probably should be able to do that stuff anyway. So if you want to go ahead and take the mid-unit exam, and then if you pass that and you do well, look at the week 6 material. It's not too bad. And then if you want to, you can do the same thing. Go ahead and take the final unit exam in week 7, and then you would be on unit 2A. So then you would be pretty well caught up, actually, and you wouldn't have to go all the way back through. So, okay, good. All right, perfect. Okay, you guys, so let's actually move on then. Is everyone pretty good? Can you reset mine again? Yeah, you know what, Dustin, I think I actually did reset yours. Check and see, and if you need it reset, Dustin, then I will reset it again. I'll double check, remind me when we're done, but I think I recalled that last night that you had opened it up but didn't get it done. So I do think that I reset it, and I might have sent you a message too, so check in Schoology to see if there's a message, but yeah, remind me too when we get off, and again, I'm at Central, so feel free if you're about to take it and you can't get a hold of me, just call over here, 326-1100, and I'll reset it, but I think I did. All right, And Tashana, I know you're in now too, so do you have any questions at all? Tashana, you are typing. Nope. Okay. So Tashana, you know you need to get through that mid-unit exam today or tomorrow, right? I just want to make sure that you pass this quarter. I just care about your passing. Yes. Get your note? Oh. Oh yeah, of course. Oh, you can just ask me if you want.
Well, I don't want to say that word.
Oh no, you know what? No one can hear you, except for Ashley and me. Okay. Oh, you need help on it. Okay, so Tashana, I think you're over at Gateway today, right? So I know that Miss Chaqua is at Gateway, and she is a great math teacher, and she can definitely help you with that, okay? And if Mr. Roth is there, he's awesome at math as well. So either of those two teachers will be really good resources for you since I'm at Central, okay? Okay. All right, you guys. Everyone else is good now? Okay. Let's look at some questions on the material then. Oops. Okay, so that was what we just talked about. Sorry, I didn't flip the slide, but that's what we just talked about. Students who started in August or early September versus mid to late September, but we talked about that. Okay, questions on material. So what I want you guys to do is put your cursor up on the hand raising guy up at the top, you know, at the very top. And I want you to raise your hand if you have a question on any of these as I go over them. So is everybody ready? Hopefully you guys are ready. So number one, finding X and Y-intercepts. Raise your hand if you don't know how to do that and you need help with that. So I'm checking all you guys out. Ivy, Alexis. Evan, okay, good. So we have a one hand raised on this one so far. Anybody else need help with that? Raise your hand. Use the little guy at the top and raise your hand if anyone else has any questions on that or needs me to show them a problem on that one. Okay. All right, let's go to number two. How about writing direct variation equations? So that was part of our warm-up. Does anybody need help writing a direct variation equation? Raise your hand at the top. That's the lightning one, yep. That was like the one we first did. And what you would do is you would see a question that said, you know, y varies directly with x. If y is 10, x is 5, write a direct variation equation. And do you need help with that, Ashley? Oh, you're good? Okay. So you guys raise your hand. Somebody, if you need help with that. And Evan is typing. So the warm-up we did is number 2. Exactly, Evan. That's number 2, yep. And you'll see it when you look in week 9. So Evan, you have some questions on that too? Okay. And Evan, part of it too is you're not in this unit yet, so some of it may all be this stuff might be a little new for you. Okay. Finally, number 3, rewriting in y equals mx plus b form. So you might be given an equation, a linear equation in a different form, and then you need to rewrite it so that it's in graphable form. We call this y equals mx plus b slope-intercept form. So raise your hand, you guys, if anybody needs help with that one. Evan? Okay, Evan. All right, good. Way to be proactive. Very nice. Okay, good. Anybody else? Okay, so it looks like maybe we'll just try one of each of these. So let's first go over what we were going to review, and then we'll come back here and we'll do some quick questions on all those. Okay, so let me, you guys, show you this. So you want to write these down if you're taking notes. A lot of people have problems writing linear equations from 2 points. But if you can do this, then you can write a linear equation from just about anything. And I think this is in week 8, I want to say. But basically, if you have a table of points, you can pick 2 points and write a linear equation. If you have a pattern, you can find 2 points and write a linear equation. I know, Leda, you basically did that on our warm-up. You took 2 points and you wrote, you found the slope, and that was the first step. So being able to write in a complete linear equation from 2 points is really, really helpful, and it will help you for the rest of the semester. So first step on this is to find the slope. And I know we go over this every time, but I think it's good because then it stays fresh in your mind. But to find the slope, you guys, if you always remember, and here's where everybody always messes up too. They always do x's on top instead of their y's. Ashley, did you have a question? Ah, perfect. See, I'm helping you. This is good. So you always want to do y2 minus y1 over x2 minus x1. And really what that is, that's just your change in your y's over your change in your x's, right? That's how much you rose, your up and down, over how much you ran, which is your left and right. So first things first, you want to find the slope. So if we find the slope, what we do is we take y2, and again, it doesn't matter which one of these is y1, which one of these is y2, but we just need to be consistent. So I'll go ahead and have this just be, let's do it in order. So we'll just say these are my x1, y1s, and we'll just call these x2, y2s. Sure. Uh-huh. It would. You got it. Very good. So Ashley just asked a question, and we're going to do that. If you have two negatives together, you would end up making it be a positive. So let's actually go ahead and solve this, and you'll see that. So we have 1 minus 9 on top, y2 minus y1, over negative 6 minus a negative 2. Now, do you guys see how I have two negatives there? So those two negatives mean, hey, we can make them be positive. So if I make this be a positive, that becomes a positive. And so my, good job. So it'd be negative 4. So I have negative 8 over negative 4, and I can reduce. Good job. Actually, nice job. And you guys, two negatives make a positive. So you end up with 2. So our slope is 2. So that was easy. So step 2 in your notes is now, because that was our slope, but that's not our whole linear equation. Because remember that your linear equation is y equals mx plus b. That's what we're trying to find. So I'll write it up here. We're trying to find, oops, y equals mx plus b. Okay. Now, in order to finish writing, we've got m, we just need b. So in order to do that, we need to plug in an x and y value. And you can pick whichever point you want. So I can pick the negative 2, 9, or I can pick the negative 6, 1. I think I'm going to go ahead and pick the negative 2, 9, but it doesn't really matter. So I'm going to plug an x, y value into my equation. So I plug the 9 in for y. I already know m because I just found it, so that's 2. And then I'm going to plug my x in for x, and I'm going to solve for b, right? I don't know b. So I'm using my equation to help me solve for b. So I would get 9 equals negative 4 plus b. 2 times negative 2 is negative 4. Okay, then I'm going to move the 4 to the other side, so I'm going to add it to both sides. And here's what I get, right? These go away. 9 plus 4 is 13, so my b is equal to 13. Any questions so far, guys? How's everyone doing so far? Those are the two biggest steps. Okay, good. Oh, that'll be in unit, I think it's in unit 3. You like that? Oh, good, Leda. Okay. B is 13, yep. So I plugged them in, and then I solved for B. So that's what I actually did up here is I solved for B. So now I just need to write it in the form of y equals mx plus b. So y equals, we said m was 2, and our b is 13. Okay, and this was my goal right here, was to write a linear equation given 2 points. So I found my slope, and then I used my equation. I plugged in an x and y in order to get my b value, and that's all I needed. Okay, and you guys, so this is a very important equation, right? This equation is a rule for all linear functions. Okay. All right, so Evan, you're typing, my internet has been slow. Okay, that's all right, Evan. You can always watch anything you need to as well. Yeah, this is recorded, so yeah, Janae, you can always go back if you need to. All right, you guys, good job. So what I want to do then is go over a couple of the things that we had questions on, and then we'll be done today. So we had some, where's our questions? Our questions were here. Oh, they were somewhere. Oh, they're back here. So finding X and Y intercepts. Okay, you guys, this is actually an important one too. It's going to help us for graphing. So let's do that first, actually. Let us find some X and Y intercepts. So we're going to do that first. So find X and Y intercepts. All right. Well, one of the nice things about this, you guys, is that when you are finding your X and Y intercepts, you already know half the points. So let me ask you guys this. In your notepads, if you're going to find the X-intercepts, what is the coordinate of Y? So type it in. What is the coordinate of Y if you're trying to find the X-intercepts? Nobody is typing. So let me just make a little graph for you guys here. How about, I'll pull one over so you guys can see a graph. Okay. Let's make it a little bit bigger. There we go. So say I'm finding my x-intercepts, right? That's somewhere here on the x-axis. So let's just say this is my x-intercept because my line goes through 4. What is, so I know this is 4, right? What is my y? What's my y right there? Leda is typing good. 0? 0, exactly right. My y is 0. All right, Evan, this is coming to you. Say I have a point right here on the x-axis, so that's -8. All right, Evan, what's my y? I know you said your internet is spotty. Hopefully this is coming in. Oh, Dustin, was that for this one? We'll assume it is. So it is 0. So good. You guys can see right now that anytime you're finding your x-intercept, we already know half the coordinate, right? The y is 0. Let's look at our y-intercept. So let's just say I pick a point up here. Okay, so I don't know what my x is at this time, but I know my y is 8. So who knows what the x is right there? Oh, Leda, you're already typing it. Very good. It is 0. Nice job. Very nice job. Okay, let's do one more. So let's put a point here at -6. Okay, who can give me the whole point? What is this point? What do you think, Shanae?
0, 2, 6,
Perfect. Good job. All right, good. So Janae and Leda, nice job. 0, -6. So this is how we can find x and y intercepts by knowing that. So let me give you guys an example, right? So say you have an equation, and I'm just going to make this up. It's 2x plus 5y equals 10, okay? So I don't know how to graph this unless I turn it into y equals mx plus b, right? Because then I have my slope and y-intercept. Well, sometimes that's kind of a pain, and we don't want to do that. So instead, what I'm going to do is just graph 2 points. I'm going to graph my x and y-intercepts. So let's do our x-intercept first. So my x-intercept, we don't know x, but we know that y is 0. Okay? So all I have to do is plug in a 0 for y, and the only thing left is x. So if I do that, I get 2x plus 5 times 0 equals 10. Well, 5 times 0 is just 0, so I get 2x equals 10. And if I solve for x, that means I divide both sides by 2. Those turn into 1, and I get x equals 5. So for my x-intercepts, when y is 0, x is 5. So there's a point that I can graph, right? Okay, let's do the same thing then for y. Okay, so if I'm going to do my y-intercepts, again, I'm kind of at an advantage because I already know that x is going to be 0, and I'm going to try to find my y-intercept. I don't know what that is yet. Okay, So what I'm going to do is I'm going to plug a 0 into my equation up here for x, right here. So I'm going to do 2 times 0 plus 5y, and that's going to equal 10. Well, 2 times 0 is gone, that's just 0, so I get 5y equal 10. If I divide both sides by 5 in order to solve for y, well, 5 divided by 5 is just 1, so y is equal to 2. So now I know my y-intercept is going to be 0, 2. So think about how nice this is for graphing, you guys. So I'm going to erase all this other stuff. If I want to graph this line using x and y-intercepts, I didn't have to rewrite it in y equals mx plus b form. All I did was come up with 2 points on the x and y axes. Okay, so I came up with 0, 2. So 0, 2 is here. That's my y-intercept. And then I came up with 5, 0. That's my x-intercept over here. Okay, and then all I have to do is connect those with a line. And I'll do that. Oops. Oh. It doesn't add up to.
It doesn't. You know how you do a problem, like a problem like this, and you have to go back and check it to make sure it's right. Like the whole problem.
Uh-huh.
Isn't it close to equal to?
Yep.
Isn't equal to with the 2, right?
So what you're thinking, so Janae, if I plug a 0 in for x,
Yeah.
and a 2 in for y, 5 times 2 equals 10, right? Because the 0 times 2 is gone.
So 5 times
5 times 2
10. 5 times 2.
does in fact equal 10. And if you do the other point, which is 5, 0, if I plug a 5 in for x and a 0 in for y, well, this is gone because 5 times 0 is gone. But 2 times 5 actually equals 10. So it does say what's that. Okay. But that's good. And you should always, double check, plug in your numbers, and make sure that those work. All right, you guys, so that's how you find x and y intercepts. So the key is knowing that half of your point on each of these is 0. Okay. Let's go back. Actually, so that was x and y intercepts. So really quick writing direct variation. If we want to look at a direct variation equation real quick, let's look at how you will get that in your week, right? So this is going to be direct variation. So in this week, you'll get something like this, or actually last week, not this week. It'll say something like y varies directly with x when y equals 4 and x equals 16. So it'll say something like that. And this is, it'll say y varies directly with x. Okay? Dot, dot, dot. It'll give you maybe a scenario. Well, you guys remember what I was talking about with slope? So this is the same thing, right? You have an x and you have a y, but since it's direct variation, you don't actually have to do y2 minus y1 over x2 minus x1. You can just put y over x, and you get 1/4. And that is our m. But for direct variation, instead of m, we say k because it's our constant of variation. So our equation would then be y equals 1/4 x. And that's all there is to direct variation. And then if I said to you, well, what is the value of y if x is 3 or x is 4 or x is 10, I would just plug that into x and multiply, and that would give me my answer. Okay. So you guys, any questions on direct variation? So that was part of our warm-up, and then I give you a quick overview. Any questions on that one? Leda, you're good? Dustin, how are you? Evan? Tashana? The K is just another name for M. So it's really your slope, basically. But the nice thing about direct variation is you can just put 1y over 1x, and you have your slope. It's almost better. It's almost easier. All right, and last thing then, if you guys are good with that. Rewriting in y equals mx plus b form. So there was one question on that one too. Okay, so let's do one with that. So let's do rewriting in y equals mx plus b form. And we do this a whole bunch, right? So hi, how are you? So we do this in every unit pretty much. So what you would have that you would need to rewrite would be, again, something in standard form, and you guys will see that soon. Or you might have it in point slope form, but again, that'll be later when you get caught up. So standard form is something like this: 3x plus, let's just say we'll do 9y. I'm making it come out nice and even. Equals 27. So this is not y equals mx plus b form. This is actually called our standard form, where you have your variables on the same side. Okay. And what we want to do sometimes is to write it in this y equals mx plus b form so that we can graph it better, because we know that m represents our slope and b is our y-intercept. We can't really do much with an equation in standard form. So the way we would do it is we would isolate y. That means we would move everything over to the right side. So first things first is you would subtract the 3x. Okay, you can subtract that term from the left side, which means we have to subtract from the right side. Well, 3x minus 3x is now gone. And you would get 9y on the left is equal to, and then I'm going to go ahead and put the minus 3x first so it's closer to the y equals mx plus b form, and then the plus 27 on the end. Okay, and then our final step is we need to remove this 9 and move it to the other side. Since it's being multiplied, we do the opposite, which is division. But here's where you have to be careful. You have to divide every term by 9 in order for it to work out. Well, 9 divided by 9 is 1, so that just leaves y. I can reduce negative 3 over 9. Negative 3 goes into itself once, goes into 9 3 times. Leave my x there. And 27 divided by 9 is 3. And now I have rewritten my equation into y equals mx plus b form. It would be easy for me to graph because I know that 3 is my y-intercept, so I put my first point there, and then I would do my slope. Notice the negative, so my line would have to slope downwards from left to right. I would go down 1 and over 3. All right, you guys, any other questions? Is there anything you want me to go over? Anybody who's taking the test that knows some kind of question that they might have, or they've done the review? Let me know. So how about everybody give me a response? So if you're good, go up to the little hand guy up at the top, and I'll show you guys because I'll have Mrs. Elliott do one. So go up to the hand guy. If you're all good, hit a green check mark with an agree. If you have a question, see how I did that over there, you guys? I made a little, can't really point over here. So Janae, you raised your hand. That's good, but do a little check mark. If you need help with something, do a disagree if you have a question. Is there any weeks I can practice these? Yep, Evan, so right now you're still in Unit 1. When you get to Unit 2, you'll be working on the stuff we did in our webinar today, actually. And there'll be a lesson too, so don't worry. There's actually individual lessons for each of these, so you can go back in and look at the lessons too. So Ashley, good. So Ashley, you can, if you're good, you can go. You're free because you did a little check mark. Dustin, I don't see it from you. And Evan, I don't see. Oh, good. Janae, you can go. Dustin, you can go. You're all good. Alexis. Are you guys good? Are those two? Okay. They're out there in the middle of nowhere. Anybody else? All right, you guys. That's it then. So that's the end of our webinar, and good luck on your exams this week for the end of the quarter, and we'll talk to you all next week.